sometimes? You have these technologies, right, designed to make everything super efficient, and then you find out they're actually gobbling up huge amounts of energy themselves.
It's a classic tech paradox, isn't it?
Totally. And today, we're diving deep into exactly that kind of puzzle.
Yeah.
The really surprising and, frankly, critical intersection of artificial intelligence and, well, the world of energy.
Yeah, and what's really fascinating here, I think, is that this isn't just, one industry consuming power from another. AI is actually deeply tangled up with the energy sector.
How so?
Well, not just as a big consumer, but also as a force that's actively reshaping how we generate power, how we use it. It's this sort of dual role that really throws a wrench into our sustainability plans.
Absolutely. We've been looking at this really compelling report from the International Energy Agency, the IEA, and it lays out this whole complex picture.
It does.
So our mission today, for everyone listening, is to really unpack this paradox. We want to get our heads around how AI, this technology that's just buzzing with promises of optimization, efficiency,
right,
is somehow also becoming a massive driver of electricity demand. But then at the same time, it's offering these really ingenious ways towards a cleaner energy future.
It's like finding out your super efficient electric car secretly has a tiny gas engine running somewhere.
Exactly. Okay, let's get into the details. Where does the report start? With the demand, I guess.
Yeah, it kicks off by highlighting the massive energy demands coming from essentially the engine room of AI data center.
Right, these huge facilities where the models get trained and run.
Precisely. They train them on these enormous data sets, deploy them for all sorts of applications. And in 2024, the estimate for their global electricity use is around 415 terawatt hours.
Okay, 415 TWH. How much is that in, real terms?
Well, to give you some scale, that's about 1.5% of all the electricity used across the entire planet.
Wow, 1.5%. That's already significant.
It is. And here's a number that really makes you sit up. That consumption. It's been growing by about 12% every year for the last 5 years.
12% annual growth. That's huge. That kind of jump, it suggests we could be facing some serious grid strains much sooner than maybe we thought.
You got it. It's like your internet bill suddenly jumping by, a big chunk every single year. It adds up incredibly fast.
Okay, so what are the projections looking like?
Well, the IEA's base case scenario, they're looking at data center electricity use rising to roughly 945 terawatt hours by 2030.
945, so more than double what it is this year, in just 6 years.
More than double. Just think about the sheer amount of infrastructure build-out needed to support that kind of growth. It's immense.
And wasn't there an even higher scenario, something called the liftoff case? Sounds very dramatic.
It does, doesn't it? But it's plausible. If AI adoption accelerates even faster than expected, and crucially, if there aren't major local hurdles to building new data centers.
Which can happen.
Oh, definitely. But if that doesn't happen, consumption could surge past 1,260 terawatt hours by 2030.
1,260, that's staggering.
Yeah.
We're potentially talking about tripling the energy demand from these places in less than a decade in that scenario.
In that high growth case, yes, potentially tripling.
So in that world, the energy needed just for data centers in, 6 years? Could be as much as the entire electricity consumption of a major country today.
Pretty much, yeah. Like a large industrialized nation. That obviously has some serious implications for our power grids, for emissions targets.
You'd think so. What does the report say about emissions?
Well, it does point out that currently the emissions directly tied to data center electricity are still a relatively small slice of total energy sector emissions, under 1.5% in the base case by 2035.
Okay, so still small, relatively speaking, but...
But, and this is key, they are among the fastest growing sources of emissions. And here's where it gets really interesting. The report is very clear. AI is a major driver behind this jump in investment in electricity demand from these data hubs.
Right, because these complex AI models just need incredible amounts of computing power to learn and then to operate.
Yeah.
It's not your standard office computer doing spreadsheets.
Not even close. The surge is largely down to the specific hardware AI needs. We're talking accelerated servers packed with powerful GPUs, graphics processing units.
Which are great for parallel processing.
Exactly. And other specialized chips like TPUs, tensor processing units, also designed specifically for AI tasks. These chips let them process huge amounts of data simultaneously, which you need for complex AI. But they also lead to much greater power density inside the data centers.
Meaning more power drawn in the same physical space.
Precisely, which puts a much bigger strain on cooling systems, on power delivery, the whole setup.
And while we might not know the exact percentage of that data center energy pie that's purely down to AI,
Yeah, the estimates do vary quite a bit. The report acknowledges that.
but it's clear it's a big chunk and it's growing really fast.
No question. AI is a primary fuel for this rapid increase in electricity demand from our digital backbone. And that growing demand, well, that's one side of this paradox we need to tackle.
Okay, so AI is definitely flexing its energy-consuming muscles, big time. But the report also paints this really compelling picture of AI as this, incredibly powerful optimizer within the energy sector itself.
It does.
Let's shift gears then. How is AI actually helping make our energy systems smarter, maybe cleaner? Or is it making the biggest difference on the optimization side?
Absolutely. And if we, connect this to the bigger picture, AI is showing really remarkable potential in making our existing energy systems much more efficient across a whole range of industries, actually.
Okay, like where?
Well, let's start with oil and gas, which might actually surprise some people as being a pretty early and significant adopter of AI.
Oil and gas. Huh. Yeah, not the first place I'd think of for AI and efficiency. How's it being used there?
The report details quite a few key areas. AI is being applied to optimize, almost every stage. Exploration, production, maintenance, even critical safety stuff.
So exploration, how does that work?
Think about analyzing vast amounts of really complex seismic data. AI algorithms can do that far more effectively than traditional methods. That leads to more reliable resource evaluations, and it significantly reduces the uncertainty before they even think about drilling.
Ah, okay. So fewer dry holes, basically.
Exactly, which means huge cost savings and, importantly, reduced environmental impact from avoiding unproductive drilling. Instead of just human interpretation, AI gives a much clearer, more accurate picture underground.
Makes perfect sense. Risk reduction, efficiency. What about during production, once the wells are actually running?
Well, during operations, AI is playing a big role in automating production processes. That allows for more consistent, efficient output. It's also proving really valuable in detecting leaks, oil or gas, much faster and more accurately than older monitoring systems.
That's huge for safety and environment.
Definitely. And predictive maintenance is another key one. AI analyzes sensor data to predict when equipment might fail before it happens.
Ah, so proactive maintenance instead of waiting for a breakdown.
Exactly. Prevents costly downtime, prevents potential environmental incidents. The report even specifically mentions ExxonMobil using an AI-powered demand forecasting model.
Oh, yeah?
That cut their forecast errors by 25%.
Wow, a 25% reduction in forecast errors in that industry.
Yeah.
That sounds like a massive deal for managing resources for overall efficiency.
It's very significant.
Okay, so that's oil and gas. What about moving away from fossil fuels? Electricity networks themselves. They're getting so much more complex now with all the solar and wind coming online.
Exactly. And this is precisely where AI can be a genuine game changer. It has this amazing ability to significantly improve how we forecast and integrate these variable renewables, the wind and solar.
Predicting the weather better.
Essentially, yes. By analyzing huge amounts of weather data, historical patterns, AI can predict with much greater accuracy when the wind's likely to blow, when the sun will shine strongest.
And that helps grid operators how?
It helps them manage that fluctuating supply much better. It reduces the need for something called curtailment.
That's when they have to basically waste renewable energy, right? Turn off turbines or panels because the grid can't handle it at that moment.
Exactly that. So better forecasting means less curtailment, more efficient use of the clean energy we generate, and ultimately lower overall emissions. It's a direct link.
So AI isn't just helping build more renewables, it's helping us actually use the renewable energy we already have more effectively. That sounds like a huge win.
It really is, and the report highlights some great examples. DeepMind's work on wind power forecasting. It reportedly increased the financial value of wind energy by as much as 20%.
20%.
Yeah.
That's substantial.
Very. And you've got major energy companies like Iberdrola with their MeteoFlow project, Enel using something called Mist AI. They're all leveraging AI to get these highly accurate forecasts for renewable output. That lets them plan grid operations better, rely less on fossil fuel backups.
Incredible. Better forecasts mean a more stable grid, less need for, firing up a gas plant when the wind drops suddenly.
Precisely. And there are other grid benefits too. AI can really boost stability and resilience.
Like how?
Well, think about power outages. AI-powered fault detection systems can find failures on the grid way faster, pinpoint the location accurately. That means quicker response times, shorter outages. The report suggests reductions of 30 to 50% in duration.
30 to 50% shorter blackouts. That's,
Wow.
wow. Everyone would appreciate that.
You bet. Plus, AI-based management of the existing transmission lines themselves using sensors and something called dynamic line rating. It basically allows the capacity of existing power lines to be adjusted in real time based on things like weather conditions. AI can manage this complex process, and the potential is to unlock up to 175 gigawatts of existing transmission capacity.
Whoa, hang on. 175 GW. That's like finding capacity equivalent to a whole fleet of new power plants, but without building new lines.
In some cases, yes, it could seriously help ease some of the grid congestion problems we keep hearing about, especially as we try to move clean energy from where it's generated to where it's needed.
That's massive potential. Okay, so supply side, grid management. What about the demand side? How we actually use energy? Buildings must be a big one.
Oh, absolutely. Buildings account for a huge chunk of global electricity use. Heating, cooling, lighting, appliances. It all adds up.
Yeah, my energy bill tells me that every month. Yeah. So how can AI make buildings smarter, more efficient?
Well, AI algorithms can analyze tons of data. Occupancy patterns, real-time weather forecasts, even those fluctuating energy prices.
Right, time of use pricing and all that.
Exactly. And based on all that, it can dynamically optimize the heating, ventilation, air conditioning, the HVAC systems. It can also make electricity use in buildings much more flexible, allowing them to respond intelligently to signals from the grid. So maybe ease off the AC a tiny bit during peak demand times when power is most expensive and often dirtier.
Like demand response, but smarter.
Precisely. And the potential savings are huge. The report suggests that if we just scaled up the existing AI-led interventions in buildings globally, we could save around 300 terawatt-hours of electricity.
300 TWH. Just from smarter building management. How much is that?
To put that in perspective, that's roughly the entire annual electricity generation of Australia and New Zealand combined.
Get out. Scaling up existing AI in buildings could free up the power of 2 whole countries. That's not just saving, that's fundamentally changing our energy needs.
It's absolutely mind-boggling potential.
And I think I read something about AI helping design more efficient buildings right from the start.
You did. AI can analyze this huge array of passive design strategies. Things like optimizing natural daylight, ventilation, choosing low-carbon, high-insulation materials, orienting the building just right for the sun.
So optimizing the blueprint itself for energy performance.
Exactly. Taking this holistic approach from day one. And that analysis suggests it could potentially cut a future building's total energy consumption by up to an incredible 85%.
85% reduction. That would be totally revolutionary for construction and for our overall energy demand.
Wow.
Okay, let's shift gears again. Transportation. Another huge energy user. How's AI making its mark there?
Well, in transport, AI is already being used quite a bit for efficiency. Things like optimizing delivery routes for logistics firms.
Saving fuel, saving time.
Exactly. Implementing predictive maintenance schedules to keep truck fleets running efficiently, improving overall operational stuff. The report estimates that just in road freight, widespread AI adoption could lead to energy savings over 1 exajoule by 2035.
An exajoule. Okay, you lost me. How big is that?
Think big. An exajoule is 1,000 petajoules, and a petajoule is 1,000 terajoules. So yeah, we're talking a truly massive amount of energy savings potential just in freight.
Right. Massive. And what about autonomous vehicles? That's all AI driven.
Yeah.
How does that play into energy use?
That's a really interesting one. Autonomous vehicles, or AVs, they hold the promise of eco-driving.
Meaning?
Smoother acceleration, smoother braking, optimized speeds, more efficient route planning, all stuff that can save fuel or electricity. Plus, they could potentially help us shift towards more shared mobility, fewer privately owned cars sitting idle.
Fewer cars overall, maybe.
Possibly. But the report is smart to point out the potential for rebound effects.
The Jevons paradox kind of thing?
Sort of. If autonomous travel becomes way cheaper and way more convenient, people might just travel more trips, longer distances. And that could potentially eat up some or even all of the efficiency gains. So it's complex.
That's a really crucial point. Tech isn't a magic wand. We have to think about the behavioral side, the whole system. Good point. Okay, one last area the report touched on, weather forecasting and climate science itself.
Yeah. More accurate, more detailed weather forecasts, powered by AI's knack for crunching huge, complex weather data sets, are obviously vital for energy operations. We talked about that with renewables and the grid.
Right.
But beyond that, AI is also becoming a really powerful tool in climate science research itself,
Yeah.
helping us build better models, understand the incredibly complex dynamics of climate change, predict impacts.
Which helps with long-term energy planning.
Exactly. Better understanding informs more effective, more resilient energy system planning for the decades ahead.
Okay, so we keep coming back to this core paradox, don't we?
Yeah.
AI, on one hand, it's undeniably driving up energy demand big time through all that computation.
Yep, the data centers.
But on the other hand, it's giving us these incredibly powerful tools to optimize energy systems basically everywhere, potentially leading to huge savings and a cleaner future. It's quite the balancing act.
It really is.
So what are the key takeaways here? And maybe more importantly, what are the actual steps we need to think about to, navigate this tricky situation?
This really brings us to a critical point. The report emphasizes several key strategies that are pretty much essential if we want to mitigate the risks from that rising energy demand from AI.
While still getting the benefits.
Exactly. While maximizing its potential to actually accelerate the clean energy transition, one really critical area is the smart, strategic integration of data centers into our existing power grids.
Okay, how do we do that smartly?
Well, first we need to avoid problems. The report highlights a pretty concerning stat. Something like 20% of planned data center projects could face major delays because of grid congestion issues.
20%. That's a huge bottleneck.
Yeah.
That could slow down both AI development and our energy goals.
It absolutely could. So the key step is much closer collaboration, much better communication between the tech companies building these things and the energy sector running the grid.
So they can actually plan together.
Right, especially understanding future energy demand better. And beyond that, we need to really leverage the innovation power within the digital sector itself to focus hard on energy efficiency at every single stage.
Now, like more efficient chips?
That's part of it, yes.
Yeah.
But also creating more energy-efficient algorithms, developing task-specific AI models, leaner, more specialized ones, instead of giant general-purpose models for everything, and constantly optimizing the code itself to use fewer resources, less energy.
So it's not just the hardware, it's the software side, too.
Yeah.
Making the AI itself less power hungry.
Exactly. It's a two-pronged approach. Smarter software, more efficient hardware.
Okay, what about the hardware?
Well, there are promising advances. More energy-efficient processors, those specialized AI accelerator chips we mentioned, and really innovative cooling tech for data centers, things like liquid cooling, which can be way more efficient than just blasting air around.
Right.
And another trend is putting more AI processing power directly into edge devices, our laptops or smartphones.
How does that help?
It offloads tasks from those huge power-guzzling CPUs and GPUs back in the main data centers. And there's also this concept called federated learning.
Federated learning.
Yeah, where AI models are trained on data locally, like on your phone, and only the learned insights get shared back centrally, not the raw data itself. That also holds real potential for cutting the energy used during AI training.
Okay, so it sounds like a really comprehensive, multi-layered strategy is needed just to manage the demand side. What about supplying the power that AI still needs, hopefully cleanly?
Well, the report has some encouraging news there. Renewables, solar, and wind, mostly, are projected to meet nearly half of the increase in global data center power demand by 2030.
Nearly half from renewables. That's good.
It is good, but just having enough total renewable capacity isn't quite enough. The report really stresses the growing importance of hourly matching.
Matching the renewable supply hour by hour with the data center's demand.
Exactly. Making sure clean energy is actually available precisely when the data center needs to draw power. So developing hybrid projects combining solar, wind, and importantly, on-site battery storage, that's going to be crucial for lining up supply and demand in real time.
Makes total sense. It's not just about the total kilowatt, it's about when those kilowatts are available.
You got it. And tackling that grid congestion issue we mentioned is also vital. One way is encouraging data centers to be more flexible about where they locate, guiding them towards areas with plenty of grid capacity and good renewable resources.
Steer them away from overloaded parts of the grid.
Right. And interestingly, the report highlights examples of data centers starting to become more active grid participants themselves.
That's so.
Things like installing their own on-site batteries, using backup generation smartly, ideally low-emission fuel, making intelligent adjustments to their cooling systems to cut peak demand, and even managing their computing workloads.
Like shifting non-urgent computing tasks to times when there's lots of cheap, clean power on the grid.
Exactly like that. So they're moving from just being passive power consumers to actively helping grid stability and efficiency. That's a really promising shift.
It really is. Okay, let's pivot back to the other side of the paradox. How do we really maximize AI's potential to actually accelerate the bigger clean energy transition?
This is where AI's innovation power really could shine. It has the potential to dramatically speed up the discovery and development of brand new materials. Materials that are absolutely critical for advancing clean energy tech.
Like what kind of materials?
Think about new battery chemistries, maybe ones that use less cobalt or lithium, relying on more sustainable, widely available minerals. Or designing better catalysts for making synthetic fuels or green hydrogen more efficiently. Creating advanced materials for carbon capture. Even formulating new kinds of lower carbon cement.
That's huge. Cement production is a massive source of CO2. The report mentioned AlphaFold, right? The protein folding AI, as an example of AI's research potential.
Yeah, exactly. AlphaFold's ability to rapidly predict protein structures was a game changer in biology. The hope is we could see similar breakthroughs in energy materials science.
Can we realistically expect that?
Well, the potential is definitely there. AI is really good at navigating these huge, complex design possibilities, analyzing tricky trade-offs, finding patterns in massive data sets, all things you need for materials discovery.
A sense of but.
But the report also notes that right now, looking at things like patents and startup activity, AI-first approaches seem kind of underrepresented in energy innovation compared to other fields like biotech or IT.
So there's a lot of untapped potential still. Why is that? What are the barriers stopping wider AI use in energy R&D?
Well, even if AI helps discover a great new material in the lab, scaling it up to industrial production is still really hard. You've got complex supply chains for new materials, often huge upfront investment needed for manufacturing, plus rigorous testing and certification.
Right, making sure the new battery doesn't explode or the new solar panel lasts 20 years.
Exactly. It really underscores the need for much better dialogue, more collaboration, more knowledge sharing between the tech world and the traditional energy sector. Bridging that gap between discovery and deployment is key.
Sounds like both sides need to understand each other's worlds much better. The challenges, the opportunities to really make AI work for the energy transition.
Absolutely. And there are other knock-on effects. That growing AI energy demand. It's starting to put a noticeable strain on supply chains for things like transformers and other grid equipment.
So we need enough electrical gear, not just for renewables, but for the AI data centers too.
Right. Keeping those supply chains resilient is going to be critical. But on the flip side, all that investment pouring into new data centers, it's also a huge opportunity for the tech sector to directly fund new clean energy, mainly through power purchase agreements, PPAs.
So big tech companies signing long-term contracts to buy renewable energy.
Exactly. It's already happening quite a bit.
And it's not just about hardware and infrastructure, right? We need people with the right skills.
Oh, absolutely critical. The report really emphasizes the growing need for AI skills, digital skills within the energy workforce itself. We need people who can develop, implement, manage these AI-driven energy solutions.
So training and education are key.
Very much so. And governments have a big role too, through funding R&D and AI for energy, setting up smart policies to manage how data centers impact the grid.
Right. And the report also briefly mentioned water use. That's another resource constraint.
Yes, good point. Data centers use a lot of water for cooling and also indirectly through the water needed to generate their electricity and make the chips. The report projects a significant increase in that water use by 2032. It's another environmental angle we have to watch closely.
Okay, so when you weigh it all up, the increased emissions from data centers versus the potential savings from AI optimization, what's the bottom line on AI's overall impact on emissions? Is it good or bad?
Well, the report suggests it's complicated, at least near term. Yes, data center energy use will definitely push emissions up in that specific area. But if AI applications are adopted widely and effectively across energy-intensive sectors,
The savings could outweigh the data center footprint.
the potential is there for much larger overall emissions reductions, yes. But, and it's a big but, those potential rebound effects we talked about earlier are a major uncertainty. We need to keep a close eye on that and have policies ready.
Makes sense.
Oh, and one other interesting point, reusing the waste heat from data centers.
Yeah.
Especially for district heating systems, say in colder parts of Europe, that's another potential win-win, turning waste heat into useful heating.
Okay. So bringing it all together then, AI really is this fascinating, complex, double-edged sword for energy sustainability.
Couldn't have said it better.
It's a major driver of rapidly rising electricity demand, which definitely challenges our climate goals. No doubt about it.
Yeah, that demand side is serious.
But at the very same time, it offers these incredibly powerful, incredibly versatile tools to optimize our energy systems, speed up clean tech deployment, and maybe, just maybe, pave the way for a more sustainable energy future overall.
Precisely. The paradox is absolutely real. And navigating it successfully is going to take a really concerted, collaborative effort on multiple fronts.
Nice one.
Like continuing to push hard on making AI itself more energy efficient, ensuring its growing power needs are met mostly by clean, renewable sources, and strategically deploying AI innovations where they can have the biggest impact on saving energy and accelerating that clean energy transition across the whole economy.
Right. It's a huge task. Which leaves me with a final thought, really, for everyone listening. Given how incredibly fast AI is advancing, it feels relentless sometimes.
It really does.
How can we, as individuals, as policymakers, as a global community, how can we proactively shape its development, shape its deployment to make sure it actually delivers a net positive impact on the energy transition? How do we dodge the pitfalls of its energy hunger while really grabbing hold of its potential to build that cleaner future? It really forces you to think about the ethics, doesn't it? And the crucial balance between, unstoppable technological progress and our fundamental responsibility.